Hey there, how's it going everybody? In this video, we'll be learning how to use the grep command from within the Linux or Mac terminal. So grep stands for Global Regular Expression Print, and it allows us to search for some text within files on our system. And this is something that you'll find yourself using all the time once you become comfortable with it. So let's go ahead and look at some practical examples where you might use this. So first of all, the most basic example is simply searching for some text within a normal file. So I'm here in my terminal, and in my current directory, there is a file named names.txt that has a bunch of random names and dummy data. So let's search this file using grep to see if it contains the text Jane Williams. So I'll just say grep and search for this name of Jane Williams within this file, and we want to search the names.txt file. So what we're saying here is we are doing our grep command, and then what we want to search, and in this case we're searching for this name, and then where we want to search. So that is within the names.txt file. So if I run that, then you can see it didn't find any results. When there are no results, it just jumps to the next line like it did here. So instead, let's search for John Williams and see if that has any results. And we can see that we got two results here where it found two lines containing John Williams and returned those entire lines. Now the second line was John Williamson, but it still found Williams within this name, so it returned that anyway. So now let's say that we only wanted it to return a match if it was the whole word. So we only wanted to search for John Williams and not return like John Williamson here. So to do this, we can use the -w option. So if I pull back up that last command that we ran, if I do a -w before our search term here and run that, then you can see that it didn't return this John Williamson. It only returned the John Williams because we put in that we only wanted whole words. Now, I also added a lowercase version of that name into that file also, but it's currently not returning that because grep is case sensitive. So we can tell it to not be case sensitive by using the -i option. And so if I pull up the command that we just ran, if I go back here and add the I to our current options and run that, then we can see that now we get the lowercase version of that match and the regular case version of that match as well. So I cleared my screen, but let me rerun that last command just to pull those names back up again. Now, just finding those matches doesn't give us information other than knowing our text is actually there, but sometimes you'll want some additional information. So for example, it's common to want to know the line number of where it found our match. And to do this, we can add the -n option to our search also. So I'm just going to pull up that last search and we can add the N option onto there as well. And if I run that, then we can see that now we're getting some information about these matches. It found this lowercase version on line 51 of that file and this uppercase version on line 431 of that file. Now, another common bit of information that you might want is some additional context of where this match is found. So we might want to also see a certain number of lines before and after the match to get an idea of the context of where this match was found. And this is especially common if you're searching for something in a computer program that you wrote and want to see the surrounding code of the match. And there are several ways that we can do this. So if we want to see a certain number of lines that come before our match, then we can use the uppercase B option. And you can remember that by thinking that, I want to see the lines behind my match. So I'm going to go ahead and clear the screen here and pull up the last option that we just ran. And now we want to add in this uppercase B option. And I'm doing this separate from the other options that we added in because we want to pass in an argument to this. So let's just pass in a 4, which will say that we want to see 4 lines before our match. So if I run this, then we can see that we got both of those matches that we got before, but now there's some additional context here. So we have 4 lines before our match here and 4 lines before our match here. Now, if we want to see a certain number of lines after our match, then we can use the uppercase A option. So I'm going to clear this out and pull up that last command and do an uppercase A instead of an uppercase B. And if we run that, then we can see that now, instead of getting the lines before our matches, now we're getting 4 lines before and 4 lines after for both of our matches. And if you want to see the lines before and after your match, then you can use the uppercase C option, and you can remember that by thinking that we want to see the context surrounding our match. And this is also the one that I use most often as well. So if we clear this out and pull up the last command that we just ran, if we do an uppercase C, and I'm only going to do 2 lines here before and after. So if we run that, then we can see that we got our matches, and there are 2 lines before the match and 2 lines after the match for both of those matches. So like I said, I especially use this if I'm searching for some text in a computer program or a function or something, and I want to see the context surrounding that match. Okay, so that is useful for finding text in a certain file, but what if we wanted to search for text in multiple files at once? So let's say that we wanted to run the same search that we've been doing, but against every file in our current directory. Now, you might think that we could just do something like this, where let me clear the screen here. So let me remove the context option here and just do the search of the whole word and not case sensitive and get the line numbers. And now let's try to search this through every file in our current directory. Now you might think that we can just do something like this, where instead of searching in a specific file, that we could just pass in the current directory as where we want to search. But if we run that, then we can see that we get this error that our current directory is a directory. So what we need to do is use an asterisk wildcard to say that we want everything in this directory. So if I rerun that same command but put an asterisk there and run that, then we can see that this worked. It said that it found a match in this memo.txt file on line 4, and also the 2 matches in the name.txt file that we saw before. Now you can see that it also tried to search in this subdirectory that we have in our current folder here, so it couldn't search that, and we got an error there. So maybe a better search for us there would be to just search all of the text files, and we could do that by running the same command and instead just adding .txt after that wildcard. So if we run that, then we can see that we got all of our matches, but that it didn't try to search this subdirectory here. Okay, so now let me clear that out. Okay, but maybe we wanted it to actually search that subdirectory. And this is very common when working on large projects. Maybe you have a lot of files and subdirectories and are searching for something that you can't remember exactly what directory or file where it's located. So in that case, you'd just want to search every single file and subdirectory in your project. And to do this, we can use a recursive search with the -r option. And using a recursive search, we actually can specify a directory as the starting point. So let's do a recursive search for our text within the current directory. So I'm going to pull up the search that we tried to do before on our current directory. Now remember, without the asterisk here, we got an error before saying that we couldn't search a directory. But if we add that -r option onto the end, it will do a recursive search, and it'll actually search all of the files and subdirectories using that R option. So if we run this, then we can see that we got those same results from within our current directory within the memo.txt file and the 2 from the names.txt file. But you can see that it also searched this subdirectory of personnel and found some matches in this emails.txt file on line 5 and this phone numbers.txt file on line 5 as well. And actually, to clean that up a bit, I could have done that without that / at the end there. So let me clear this out and rerun that same command there, and that just cleans it up a little bit. Okay, so that's nice that we were also able to search that personnel subdirectory and get the matches within there as well. But you do want to be careful with recursive searches, just because if you're in a big directory that has a ton of subdirectories, then it's going to try to search all of those and could take an extremely long time to return any results. And if it takes too long, you might just have to kill it. So just be aware that those recursive searches could be searching through lots and lots of files. Now, if you're searching through multiple files like this, then you might not actually be interested in the matches themselves. You might only be interested in seeing what files contain a match. And if you only wanted that information, then you can add on the -L option and only return the files with matches. So if I pull back up our last command and go back here, and I'm going to take off the N that shows the line because it wouldn't show this here anyway. And then I'm going to add on the L, and this will just show us what files contain a match. So if I run this, then we can see that that it doesn't display the match. It just comes up and says that we found a match in memo.txt, names.txt, and all the matches within that subdirectory. And if you remember, we actually had 2 matches in names.txt file, but this result just returns names.txt once because it's just listing any file that has a match. Now, if we wanted to see how many matches are in each file, then we can use the C option. So if we pull back up, let me clear the screen here. If we pull back up the command that we just ran and instead replace that L with a C and run that, then we can see that we get some similar output as the L option, but it also displays the number of matches in each file. And don't worry about this dsstore file here. That's just something that pops up on the Mac sometimes. Okay, so now let's look at one practical use case for using grep that we haven't covered yet. So we can pipe the output of other commands into grep to search for certain things. So for example, let's say that we wanted to search our history for our latest git commits. So if we just display our history, then we can see that if we wanted to find our git commits, then there's a lot of information here to sift through. So let's pipe this into grep to narrow it down a bit. So we could search for all of our git commits and our git history just by saying, so first let me clear the screen here so that we can see a little bit better. So we can just run history like we did before, but now we're going to use a pipe and pipe that in to grep. So now we'll say that we want to grep that output for git commits. So if I run this, then we can see that it narrows down our history to lines that match our grep search. And we can even pipe this output into another grep command to narrow it down even further. So if I only wanted to see git commits about dot files, then I could run that same last command, do another pipe and another grep, and instead grep for dot files. So first, it's going to pass the output of history and narrow those down to the ones that have a git commit, which are all right here. And then it's going to take this output and pipe that into grep again and search for the ones that have a dot file match. So if I run that, then we can see that now we only get our git commits with the dot files. Okay, so now let me clear this. Okay, so we're just about finished up, but I wanted to show one more thing here. So let's see how we can do some more advanced searches using regular expressions. Now, I'm not going to go into detail about how to write regular expressions in this video, but if you're interested, then I'll put a link to my regular expression videos in the description section below. So grep uses POSIX regular expressions by default. Now, if you've watched my other videos on regular expressions, those videos are actually using something called perl compatible regular expressions, which is also what Python uses as well. So let me show you how this might affect your grep searches. So let's say that we wanted to search a file for phone numbers. So we might do something like this. So I will do a grep, and now we'll write our regular expression. So I'm just going to do something simple. I'll do ... and the dot in a regular expression is just matches any character. So then I'll do a dash, and then ... and then a dash, and then ... So this will find any 3 characters, then a dash, then any 3 characters, then a dash, then any 4 characters. So this should match a phone number. And now let's pass in the file that we want to search. So we'll search names.txt. So if I run that, then we can see that that works and that we got back the phone numbers from that file. But let's say that we wanted to make our search a little bit more specific, and instead of searching for any character using the dot, we wanted to search specifically for digits using \d. So if you've seen my other regex videos, then you might think that we can do that search with something like this. So let me erase this. So let's say that we want to only get a digit. So we'll do a \d, and we want 3 of those. So I'll pass in 3 as the quantifier there, and then a dash, and then the same thing, a digit and 3 of those, and then a dash, then a \d for a digit again, and 4 of those. So now if we run this, then we don't get the results that we expect. And that's because grep isn't using perl compatible regular expressions, which is what that is. So can we get those perl compatible expressions to work? Well, if you're on Linux, then you can get this to work just by passing in a dash uppercase P here before the search. But if we run this, If you're on a Linux machine, then that would work, but I'm on a Mac and we can see that it doesn't. Now, we can get this to work on a Mac, but it's a little complicated. So this next step is completely optional, but you can follow along if you want to grep using these regular expressions on a Mac. And if you're using Linux, like I said, then you won't have to do this step because Linux already has that functionality. So in most of these Linux and Mac tutorials, all of the commands usually run the same on both systems for the most part, but these grep regular expressions are one example of something that is different between Mac and Linux. Mac uses a version of grep called BSD grep, and Linux uses a version of grep called GNU grep. And you can see that version if you type grep and then -uppercase V, and you can see that here we are using BSD grep. And many people prefer the GNU version of grep, and that's what I prefer as well. So I'll show you a trick for how you can actually install the GNU version of grep on the Mac by installing it through Homebrew. So if I pull up Homebrew in my browser here, so I'm just in Chrome, and this is at brew.sh. Now, if you've never used Homebrew, it's basically a package manager for the Mac, so you can follow through the installation instructions from their website, and once you have that installed, you can open a new terminal, and then you should be able to install the GNU version of grep just by saying, let me clear out my screen here. We can install this by saying brew install grep, and we also want to add in some options here. So we'll say with default names. The with default names option means that it will install it as grep, and if you leave that off, then it would actually install it as ggrep, which would allow you to use both the GNU version of grep and the Mac BSD grep, but GNU grep as the default is fine with me. So I'm going to go ahead and run that, and I will let this installation finish. And once that's finished, we'll likely need to open up a new terminal for that change to take effect. If I do a grep-v, you can see we're still using BSD grep. So let me open up a new terminal, and I can maximize this. And I am in full screen mode here, so let me take this down and then pull this tab out here into its own window. Now let me make this text larger so that everyone can see still. Okay, so now if I say grep-v in our new window, then we can see that now we are using GNU grep, so that's what we wanted. Okay, so back to our example. The reason we did all that was so that we could use the Perl compatible regular expressions on the Mac, and the GNU version of grep accepts that -uppercase P option that tells grep that we want to use those Perl compatible expressions. So if I go back to my other window here and grab that command that didn't run before on the Mac. So this is still using the BSD version. If I run that, you can see that we get an error. If I navigate to my desktop and the demo directory, that's where I was running those searches in the other window. Now, if I paste in that command that didn't work before, then we can see that by using that uppercase P option that we can now get the results that we expect. And we can use these regular expressions with the options that we saw before too. So if I wanted to do a more advanced search and see what files contain phone numbers under my current directory, then I could do something like this. So let me pull up the last command that we just ran, and let me make this text a little larger just one more time here, okay? So if we wanted to see all the files that contain phone numbers under our current directory, then what we could do is I could pass in my current directory as the search location, and back here with our options, we want to keep that uppercase P so that we can use our regular expression here. And now let's also use some options that we saw before. So I'll use a W for the whole word search. I'll use I for case insensitive, even though that doesn't really matter with this current regular expression. I will use R to say that we want a recursive search. Since we're running this on the current directory, it will also search the subdirectories. And remember, the L is what displays the files that contain our match instead of the matches themselves. So with all of those options in place, if I run that, then we can see that it found phone numbers in our names.txt file and our phone numbers file within the subdirectory. And you can do all of the other searches with regular expressions that we saw earlier in this video as well. Okay, so I think that is going to do it for this video. Hopefully now you have a pretty good idea for how you can use the grep command to search for patterns of text in a lot of different ways throughout your file system. But if you do have any questions about what we covered in the video, then feel free to ask in the comment section below and I'll do my best to answer those. And if you enjoy these tutorials and would like to support them, then there are several ways you can do that. The easiest way is to simply like the video and give it a thumbs up. And also it's a huge help to share these videos with anyone who you think would find them useful. And if you have the means, you can contribute through Patreon, and there's a link to that page in the description section below. Be sure to subscribe for future videos, and thank you all for watching.